In section 4.2, let's take a look at a couple other examples of modeling with linear functions. So suppose the owner of a grocery store finds that she can sell 980 gallons of milk each week at $2.69 per gallon and 1,220 gallons of milk at $2.49 per gallon. So we want to write a linear function g of p that gives the number of gallons sold as a function of the price of the milk. Okay, so to start, I'm going to write a couple of ordered pairs using this given information. Notice that they're going to be of the form p then g, since p is the independent variable and g is the dependent variable. Okay, so the first one, price is $2.69 and the number of gallons is 980, and then the other ordered pair is $2.49 with 1,220 gallons. And because we're trying to write the equation of a linear function, we first need to know what the slope of the line is. So let's use the slope formula. Okay, so in this case, it'll be G2 minus G1, or 1220 minus 980, divided by P2 minus P1, or 249 minus 269, or negative 1200. Since we're not given the y-intercept, we may want to use point-slope form and then convert the equation to slope-intercept form. Okay, so remember that point-slope form looks something like this. Y minus y1 equals m times x minus x1. And in this case, because our variables are different, we could have g minus g1 is equal to m times p minus p1. Okay, so we're just going to pick one of these points. It doesn't matter which one, and we'll substitute the p and the g value into this formula. And then we also need to substitute the slope, which was negative 1200. So we'll have g minus 980 is equal to m negative 1200 times p minus 269, and then convert to slope-intercept form. So after distributing the negative 1200 to the p and the negative 269, we get g minus 980 is equal to negative 1200 p plus 3,228. And then lastly, isolate g by adding 980 to each side. And we get a function g of p, which is negative 1200p plus 4,208. So in part B, we're asked to graph the linear function. And luckily, we have 2 points already given. And so we're just going to graph these ordered pairs and ensure our line passes through them. Okay, so 269, 980. We're going to first go to our p-axis, which is the price, and then we will go to the g-axis, which is the number of gallons of milk. So 269 is going to be somewhere in here, and then up to 980, which is very close to 1,000. So we're going to have a point somewhere in this area. And then 249, 1220. So 249 is very close to 250. So very close to this tick mark right here. And then 1220, which is a little over 1,000. And so we'll say that that's somewhere in here. And if it was difficult to plot those points, one other thing that you could easily do is to go back to your x and y intercepts, or your p and g intercepts in this case. The g intercept can be found by looking back at the function formula that we wrote, where the y-intercept was b, or 4,208. Although we didn't find the p-intercept, we could pretty easily. And so that would be found by setting g equal to 0. And solve for p, and we get about $3.51. And lastly, according to the function, if the owner sold 800 gallons of milk, what was the price per gallon? Okay, so g of p, again, is negative 1,200p plus 4,208. We're given how many gallons of milk was sold, which was 800. We have a new equation. 800 equals negative 1,200p plus 4,208. And to solve this equation, first subtract 4,208 from each side, and then we'll divide by negative 1,200. So we have p equals negative 3408 divided by negative 1,200, or $2.84. And lastly, you're choosing between two different prepaid cell phone plans. The first plan charges a rate of 26 cents per minute. The second plan charges a monthly fee of $19.95 plus 11 cents per minute. How many minutes would you have to use in a month in order for the second plan to be preferable? Okay, so we're going to first start by writing formulas for each. So we'll say the cost of plan 1, C1, is equal to 26 cents per minute. And so if we let M be the number of minutes, then we can write a function as 0.26. We could use 26, but I think it would be easier to think about the cost of our plan in terms of dollars. So I'm just going to go ahead and convert it to dollars. So 0.26 M. Okay, and then the cost of the second plan is $19.95 plus 11 cents per minute, so 0.11 M. Okay, and then the goal is to see how many minutes would you have to use in a month in order for the second plan to be preferable. Okay, so what we're looking for, a preferable plan, is one that costs less. So in other words, C1 would be bigger than C2, or C2 is less than C1. That's what we're looking for. So we're just going to set up this inequality. 0.26 M is greater than $19.95 plus 0.11 M, and solve this for M. So to do that, we'll first subtract 0.11 M from each side, and we get 0.15 M is greater than $19.95. And then lastly, divide each side by 0.15. And we see that M is greater than 133. And what that tells us is that the number of minutes you would have to use in a month in order for the second plan to be preferable is something more than 133 minutes. So 134 or greater.